In this video, I want to talk about finding the areas of parallelograms and triangles. The last couple of years, I've gotten a feeling from people that perhaps people have oversimplified the idea of area. I had a handful of people last year who just thought whatever the shape was, you just take two sides and you multiply them together and you get an area. And so I don't know if they're thinking of that as a base times a height or a length times a width. But if you remember from the previous video, area is counting how many squares you can grid a shape into. That's all that area is coming back to. And so really what we're trying to do is we're trying to come up with as many different strategies as possible that allow us to figure out how to grid off a shape into different squares, okay? So a parallelogram. You could be given different measurements about a parallelogram and you're gonna have to decide what values to use, okay? So they might give you a base length, they might give you another side length here. They might also give you an altitude, perpendicular to one of the sides, all right? And people who kind of cut some corners when they were in third grade didn't really understand what area was and just kind of memorized something that didn't really make any sense to them, will just kind of go, it's probably 6 times 10. Okay, that's not how you find the area of a parallelogram, okay? Currently, the only thing we know how to do is how to find the area of a rectangle, okay? So if you notice here, I can actually take this altitude over here, and I can move that altitude anywhere I want, right? Because those opposite sides are parallel. So I'm gonna move my altitude over here. Okay, remember the altitude was 5. Okay, so I get a little triangle right here, okay? Remember that opposite angles of parallelograms are equal, the consecutive angles are supplementary. If I break off this triangle and I pick it up and I move it over here, notice that length right there has just got moved here, okay? So this whole length is still gonna be 10, okay? That didn't change. I just moved the part that was here over to here. But if you notice something, I've now turned this into a rectangle. I know how to find the area of rectangles, okay? If I gridded this thing off, this is a 5 by 10 rectangle, not a 6 by 10 rectangle, okay? Notice the 6 is just cutting down in the middle. It has nothing to do whatsoever with the area, okay? What this implies is you don't multiply the side lengths together to find the area of a parallelogram. You multiply the base length times the height. And remember, a height is an altitude. It always is going to hit your base at a perpendicular, okay? So if you use that formula, area equals base times height for a parallelogram, that actually matches up with the formula that I gave you for a rectangle, okay? So a parallelogram's area is equal to the length of the base times the height, okay? Not the product of the two side lengths, okay? So you notice here we get 5 times 10, the area would be 50 square units, okay? If I went back to the original shape, and you don't need to show this thing being broken up every time, okay? If I go back to the original shape, I don't remember what it looked like now, but maybe something kind of like this. We had a 6, we had a 5, and that whole length was 10, okay? Notice, it's the entire base length of 10 times the height of 5 gives me an area of 50. Okay, you should not have to show it being broken up every single time. Base times the height, not times the side length, okay? But that's why it works, because the shape hypothetically could be turned back into a rectangle, okay? Other examples. So area of a parallelogram is equal to the base times the height. This parallelogram, you'll notice, they didn't give me a height. The height would be right here. It's probably gonna be less than 8, but the question is, what is it exactly, all right? Be on the lookout. If they give you angle measures, we know a lot about angle measures now. And this angle measure in particular, that's a 60-degree angle. Remember, an altitude hits a base at a right angle. Drop that altitude into the base right here. You can make a little right triangle. And not just any right triangle, it's a 30, 60, 90 right triangle. So remember, the hypotenuse is twice the length of the short side. Now, 4 is not very important to us because we need the whole base of 10. But we can use it to find the altitude, okay? The altitude is gonna be 4 radical 3, okay? So this means nothing to us. That means nothing to us. We have the base and we have the height, Okay? By the way, when you're working with formulas, I really do want to see what your setup is, okay? So get in the habit of writing your formula down. Area is equal to base times height. And even if you're typing this in a calculator, make sure I can see what goes in, okay? So in this particular case, the area is equal to the base of 10 times the height of 4 radical 3, okay? And the area is going to be equal to 4 radical 3. And again, you really should say square units or do a u with a square after it, something like that, okay? But make sure I can see your formula and make sure I can see what numbers go into your formula, all right? Talk about areas of triangles. So you might wonder why I'm doing triangles in the same video as parallelograms. There's a reason. So if I just draw a random triangle, and most of you probably already know the formula for the area of a triangle, but I want you to know where it comes from. If I draw any triangle, I can create a congruent triangle, and I can flip it over. And if I create the same triangle again and flip it over and put it right here, I can create a parallelogram, okay? These are alternate interior angles. That's going to create some parallel lines. These are congruent alternate interior angles. That's going to give me some parallel lines. Anyway, the point here is I actually have a parallelogram, okay? If you know the base and the height of the triangle, you would also have the base and the height of the parallelogram. So let's say that this triangle had a base of 8. And let's say that its altitude was 5. Remember, an altitude or a height will always go from the vertex down to the line containing one of the bases at a perpendicular. Okay? Now I can find the area of this parallelogram. All right? The area of that parallelogram is the length of the base times the height. Okay? Base is 8, the height is 5, the area of that whole thing is 40. Okay? But I wasn't trying to find the area of a parallelogram. I was trying to find the area of a triangle. And the triangle it made up 1/2 of this parallelogram. Okay? And what that tells me is it's going to be half the area of the parallelogram formula. Okay, so I can take 8 times 5 and divide by 2. I usually am going to write the formula as 1/2 the base times the height. Okay, you may have learned it as base times height divided by 2. That's the same thing. Anyway, in this particular case, half of 8 times 5, half of 8 is 4, 4 times 5 is 20 square units. Okay, that would be the area of the triangle. All right, let's look at some other cases, areas of triangles. So write down this area formula here, half the base times the height, or base times height divided by 2 if you prefer. Okay, some other cases. Number 1, let's look at an equilateral triangle. So let's say I have an equilateral triangle and the side lengths are each 8. Okay, I have a base. Okay, the area is going to be 1/2 the base times the height. I already know the base is 8. Okay, that's not a height. Okay, the altitude has to be perpendicular to the base. So if I draw that perpendicular in here, because this is equilateral, we're going to get 2 congruent triangles. Not only that, think about the angle measures here. An equilateral triangle has 60-degree angles. Okay, that's a little 30, 60, 90 triangle. Okay, that's going to be half the side length. Double it to get the hypotenuse, and that side is going to be 4 radical 3. Okay, so the base is 8 units, which we had from the original. I filled that in. The height is 4 radical 3. Okay, so I'm going to take 8 times 4 radical 3, which is 32 radical 3. I'm going to take half of that, 16 radical 3 square units is going to be the final area for that equilateral triangle. All right, so that's something you might see. Other things you might see. You might see a right triangle. Okay? In fact, let me draw it like this. Let's say you had a right triangle that looked like this. Let's say it was a 3, 4, 5 right triangle. Okay? Now the formula says you're going to take half the base times the height. You're probably looking at it like, oh, look, the base is 5 here. I need to find the height here, and I don't know what it is. Okay? I don't know what the height is either. It's not the way you want to go about doing this problem. Okay? remember, triangles have 3 different sides. Sometimes if you turn it to a different side, you may already have the height, okay? For example, if I turn it like this, I can use the 4 as the base and the 3 as the height. Or I could turn it this direction, I could use the 3 as the base and the 4 as the height, okay? 5 has nothing to do with anything. The key here is I have a side and I have another side that's coming down perpendicular to it. That can serve as the height, okay? So the area is going to be 1/2 the base of 4 times the height of 3, okay? 3 times 4 is 12, half of 12 is 6 square units. And you can see the same thing here, 1/2 the base times the height there also gives you that same area of 6 because it's the same triangle and the area is not going to change if you turn it into a different position, okay? Let's look at obtuse triangles, okay? Let's say I had an obtuse triangle, maybe a triangle looking something like this. And let's say that this side length here is 8, and maybe this side length here is 10, and maybe this is a 30-degree angle right here, okay? The area is still 1/2 the base times the height. But remember, sometimes the height in an obtuse triangle is on the outside of the triangle, okay? In this particular case, if I'm going to use 8 as the base, my height would actually be out here, okay? It's not going to touch one of the sides. It's going to touch the line that contains the base, okay? So if I handed you a tape measure and I said, hey, how tall is this triangle? You put the tape measure there, even though that's not one of the sides of the triangle, okay? Now, this does not become part of the base. The base is still 8 units long, okay? It's just the height is this length right here. By the way, notice something. So I'm going to dot the rest of this in. Again, still just trying to find the area of this triangle, and it's still that formula. Notice this is a 30, 60, 90 triangle. That would be a 60-degree angle right there, okay? Remember, you take 1/2 the hypotenuse to get the length of the short side. That height's going to be 5, okay? And at that point, I have a base of 8. Remember, this is not part of the triangle, okay? The base is 8. The height is 5, okay? 1/2 of 40 is 20 square units, and that would be the area of my triangle, okay? So the formula always works, but you need to make sure you're dealing with the base of the triangle and the actual height, the altitude, to a perpendicular. And again, if you don't have a perpendicular, you may have to put one in. You may have to turn the triangle different directions to get the part that you need. But that's the idea. So hopefully not too bad finding the areas of parallelograms and finding the areas of triangles.